we'll learn in Algebra 1. From the moment we're born, we start to see patterns in the world around us. We learn words to describe the things we see, and we start to put things into categories. A toddler can point to a dog she's never seen before and know exactly what it is. She knows what makes a dog because all dogs bark, pant and wag their tails, just as we make generalizations about the patterns we see in the world. We make generalizations about the patterns we see in numbers, and algebra gives us a language to describe these patterns. In this course, we'll learn how to use variables to represent unknown values, and then how to use algebra to figure out what those values are. To be sure, there are countless ways to apply algebra in the real world, but most people don't use a lot of algebra to solve day-to-day problems. The real value of algebra is in what it trains your mind to be able to do. It shows you how to recognize patterns, follow procedures, justify results, and become a logical thinker. And these are the skills that will be most useful to you in the future. We'll start the course with operations, where we'll cover the arithmetic operations of addition, subtraction, multiplication, and division, but this time with variables, which are letters we use to replace numbers. So instead of adding 3 plus 3 or 3 plus 4, we'll learn how to add x plus x or x plus y. Or instead of multiplying 5 by 5 or 5 by 8, we'll learn to multiply x by x or x by y. In the next section, we'll start solving equations, which are mathematical statements that two values are equal. Specifically, they tell us that everything on the left side of the equal sign has the same value as everything on the right side of the equal sign. When we start writing simple equations with variables, our goal will be to realize here that the value of x has to be 6 in order for the equation to be true. And we'll establish rules that will help us find the value of x no matter what the equation looks like. Then we'll dive into polynomials, which are sums of algebraic terms. Polynomial literally means the sum of many terms. So think about polynomials as having place values. Just like the number 543 has a 5 in the hundreds place, a 4 in the tens place, and a 3 in the ones place. We could therefore rewrite 543 this way, and then transform that expression into a polynomial by replacing each power of 10 with a power of x. Because of this connection, the procedures we use for polynomial arithmetic will be similar to the ones we learned for whole numbers. At this point in the course, we'll turn toward factoring, which is really just about undoing multiplication. In the last polynomials group, we'll have learned how to take something like x minus 3 times x plus 4 and multiply it to get x squared plus x minus 12. But now we want to go the other way and figure out how to break down or factor the polynomial. Once we know how to factor simple polynomial, we'll start to find the values of x that satisfy quadratic equations like these ones. The first half of the course is all about tools for our algebra toolbox, and in the second half of the course, we'll turn our attention toward putting some of those tools into practice. We'll start in the functions and graphing section, which is all about the input-output pairs of an equation. We'll learn about the rectangular coordinate system, and then how to graph points and lines, where a point is a single input-output pair, and a line is a collection of all the input-output pairs that satisfy a linear equation. Then we'll look at functions, which we can think of like vending machines, where we input a number into the machine, and the vending machine gives us back a specific price. Each number we punch in gives one and only one price. So we'll learn how to determine whether an equation represents a function, how to add and multiply functions, and how to determine whether the function has any kind of symmetry in the coordinate plane. Then we'll turn toward inequalities, which are just like equations, except that these statements specifically tell us that two values are unequal in some way. We'll start by looking at inequalities that tell us that the left side of the statement is less than the right side, or that the left side is greater than the right side. And of course, just like with equations, we'll add variables to the inequality statements so that we can learn to find the set of values x that makes the inequality true. Finally, we'll look at how to solve systems of equations, which are pairs of equations where we're looking for the set of values that satisfy both equations in the system at the same time. Given this system, we can find that the pair x equals 4 and y equals 6 is a solution because the 46 makes both equations true simultaneously. In this last section, we'll learn different methods for solving system of equations like this one, including substitution, elimination, and graphing.